Hello everyone, I'm Alejandro Martinez, and in this video I'm gonna make a code review showing you little demo that I did from an application during Christmas. The idea was if there was an easy way to capture the windows of your computer, and this video is highly inspired by the artsy code reviews that Orta and Hash have done and have published on YouTube. They are like highly inspiring for everyone, like to see how they explain the code that they have been reading, the struggle that they have been having with it, and like the good parts, the parts that needs to improve. All of that has been really interesting for me. I also was really interested in doing like a live coding with the streaming and Twitch and all of that, but I've never done it honestly, and I'm a little scared of doing it sometimes. So this video is like a small step on getting rid of this fear. As I was telling you, that the application that I'm gonna show you is it's a demo extracted from a side project that I was working on, because I'm not sure if I'm gonna finish it honestly. But at least I extracted this interesting part. The app itself is really simple. There are already APIs to do this window capture, and the API is really simple, but it's an old API, so I took the opportunity to build a small wrapper to make it prettier in Swift, and also adding some FRP concepts on top. In this video I'm gonna start showing you what the app does and the code behind. The app is really simple, so there is not much to see, but I thought that it was worth sharing it, maybe for the newcomers or the ones that are starting with FRP. Even I'm not that expert. I've been working with FRP in some side projects, but I've not been working in my day-to-day code base. What you see here is the demo application. Basically, you have a list of the windows that are like currently visible on your desktop. The list automatically gets refreshed. For example, if I go down, you can see that the dog appears as the first position, and also you can see that when you select a window, it gets constantly refreshed with the content of the window. In this case, it's a video let's play of a game that it's running on the background, and you can see how it automatically gets refreshed every second. A funny effect is that you can capture the application itself, and it gets into this infinite loop. It's really interesting and really fascinating. So let's start by taking a look at the main storyboard. I've used almost always storyboards in my application for the side projects. I think it's a really useful technology and that people should embrace it. Basically, in this storyboard I have like a main window, nothing special here, that has a SplitView Controller. So you can see that in the left I have the list view controller, and on the right the image view controller. Each one of them like doesn't have anything fancy, honestly. It's just a table view. Maybe the interesting part here is that it's a cell-based table view, so just for simplicity. And the other view controller is just a wrapper on top of an image view. On the code side of things, let's start by the image view controller. It's basically the easiest one, but there are a couple of things to see. First of all, see that there is no logic at all on this view controller. The only thing that it exposes is this image variable and as image, this image property, that when it gets set, it automatically updates the image on the image view. As you can see, the image view is private. I'm just putting this really to ensure that nobody accesses it, because that's the important part. The public API of this view controller is just this image. The Windows list view controller is being done in a similar way. It exposes a Windows property that it's basically an array of strings. That's basically what the table view displays. Every time that this array of strings is set, the table view gets reloaded. This view controller, it also exposes another property. Window did change Basically, it gives the consumer of this view controller a way to detect when the user selects a different window on the list. Again, the table view itself is completely private, so nobody apart from this view controller should touch it. This view controller uses a couple of extensions to implement the table view data source and the table view delegate. I find this style in Swift really interesting because it really demonstrates to the reader of this code that these methods could go anywhere on the app, that this view controller itself doesn't depend on this. You can create another object and delegate to that object if you want, it doesn't matter, because they're in an extension. In the same way, we have the table view delegate here, like basically does the same thing, but the important part here is that the view controller itself doesn't know anything of what it has to do when a new window, a new index of the table view is selected. It just delegates and informs using this function to somewhere that something has happened. It doesn't know anything else. Let's see now the wrapper on top of the Quartz. Window is a struct that it's the wrapper on top of the Quartz API that lets you screenshot basically windows of your system. The Quartz API is based on C, on standalone functions that return data in dictionaries. This window struct represents a window with the information from one of those dictionaries. Owner is a nest type of a window, so everything gets really organized thanks to the Swift. As you can see, the content of this struct are just simple properties, simple let properties that basically use the same types as the Quartz API exposures. They need method of window receive a dictionary that it's based on the information that gets returned from this API. Honestly, it's probably really error prone. As you can see, I'm just forecasting everything and I don't give a crap about the result. Basically, this is because I was exploring the API, so I needed to crash as soon as possible to see where my expectations were okay and where my expectations were failing. Right now, the API, it's really stable. It has been there for years, so I don't expect it to change. So if some of these expectations change at any point, I'm interested in see exactly what the problem is and not try to come up with a nicer fallback. It's worth noting that some of these properties, like the name, need a fallback because they are not always there. For example, a window may not have a name for some reason, and actually it happens a lot of times because this API exposes, depends on the parameters that you send, a lot of windows that you don't really see on the system but are there, like for example like windows that the items on the status bar of the operating system use. A lot of these windows doesn't have any name, so it's usually we should at least give a fallback so nothing crashes in this case. The capture function in the window, it just returns an image. It uses directly the API that it's provided with some default parameters. The window has an extension that provides the static methods. The main one is the all windows. It's basically the main entry point to this API. It has a couple of parameters, but all of them have defaults, so all of them are optional. The nice part about this function is this filter parameter. A filter is basically a function that, given a window, it will return yes or no, saying if it passes the test. The nice part is that this function already uses a basic filter, a default filter. This is because what I was saying before, that the system gives you a lot of windows that are not really important, so this basic filter tries to get rid of these windows. But the best part for me, in my opinion, is that this function is exposed. It's a public function. It lets the client of this API basically compose this function with their own functions. I've seen in a lot of cases that when you try to override a default behavior that an API has, you lose that default behavior and you have to re-implement it by yourself. With this approach, you can implement your own behavior but keeping this basic filter, just composing it yourself, which I think is really nice. Now let's talk about FRP. I'm using here RxSwift, but you could do exactly the same with other frameworks. I've been using Reactive Cocoa since my first steps on FRP, and honestly, I was just trying a different framework for this project. The capture function is basically a replica of the one that we saw before. The only difference is that this returns an observable of images, not just the current image. The first step that you're gonna do in FRP is create one of these. This case is really simple. Just create a timer with the interval. The interval by default is 0 seconds. It means that this will try to capture the window as fast as possible. There is a trick here that I'm gonna show you later that basically throttles the capture process automatically depending on what the client side is doing. The important part here is notice that you have to return this disposable that when it gets disposed, it cancels the timer. So this signal, this observable, stops immediately. Doing the same that we have on the window, here we have a static function that gives us all the windows. The only difference is that now it's an observable of an array of windows. Again, the case is the same, like the code is practically the same as in the other case, like just making sure that we stop the timer when it gets cancelled. And as you can see, the only thing that it does is call the original function. These couple of functions are an extension on the observable type. It's just to show you how easily it is to extend these FRP frameworks. It's not just this one specifically, it's all of them, because it's based in functional concept. It's so easy to compose everything you are creating, like all the small pieces, put them together. In this case, I use this to debug all the change of operations that I'm creating, because sometimes you are not sure of what's going on. So it's an easy way to debug that kind of thing. And finally, let's take a look at the SplitView Controller. This is the view controller where everything comes together. Here we set up the binding between the windows that the system has that we are getting using this method that I just showed you. Then we map this array of windows with another array of windows, but in this case it gets sorted by name, so we always have a consistent list of windows. And then we send these windows over to the main thread, the main scheduler, and there it's where we subscribe. Here I'm using that property window did change on the list view controller to start observing the screenshotting process that gets fired. One important part of this is that every time that this gets created, because I'm creating a new signal, what I have to do is create a new dispose bag. So the previous one gets completely disposed, the timer stops, and we stop making screenshots of the old window because we don't care anymore. We map the original core graphics image to an NS image. I'm here just simulating an intensive task because that was the use case that I was having on the original application. And here is where the trick that I was talking before happens. Because I'm not changing the scheduler where all these processes are happening. This means that this intensive task will basically block the same scheduler where the capture is being done. It means that basically here I'm throttling the capture process automatically without having to think about it. I'm sure there is a better way of doing this, and if someone has better ideas of how to handle this, I will be happy to hear them. The only last bit is that when the Windows list is received, we set the windows to this property on this view controller to keep track of them, and again the did set gets fired, and we only map the list of windows to a list of strings composing the owner's name of that window with the name of that window, and that's what we see on the table view. So that's all. It's a really simple app, but I've been able to show some concepts on separating concerns from the view controllers and using FRP. I hope you learned something with it, and if you have any feedback, you can send me a tweet or you can contact me via my website. Apologize if I butchered the English language or even some of your ideas of programming. I hope at least you have taken something from this review. Thank you very much for watching.